On August 10, 2018, a 29-year-old ground service agent clocked into his shift. His experience was limited to towing planes and loading luggage, yet by that evening, he was no longer standing on the tarmac. He managed to bypass security, taxi onto a live runway, and steal a 76-seat, multi-million-dollar commercial turboprop aircraft. Once airborne, he threw the 67,000-pound machine into barrel rolls and near-vertical climbs, maneuvers that seasoned pilots thought would physically tear the airframe apart. Gravity is an absolute. To break its hold requires an immense, orchestrated force. How does an untrained individual physically command that level of raw power? To understand the magnitude of this event, we have to investigate the mechanics of propulsion, starting exactly where he did, on the ground. A modern airport apron is a swarm of ground support equipment. Baggage loaders and aircraft tugs move in a constant choreography, increasingly powered by electric motors. The electric car motor is a masterpiece of contained engineering. It operates as a closed loop, generating power without ever needing to breathe. Inside, the physics are built on two main components: an outer, stationary ring called the stator, and an inner, spinning cylinder called the rotor. The process begins when alternating electrical current is pumped through copper coils in the stator in a specifically timed sequence. This electrical pulse generates a powerful, invisible magnetic field that rapidly sweeps in a circle around the inside of the stator ring. Because the inner rotor is also magnetic, it is dragged along by this rotating field. It constantly tries to catch up, generating the instant rotational force, or torque, that moves the vehicle forward. It is an elegant, silent way to generate massive power. There is no exhaust and no combustion, just the precise manipulation of magnetic fields. But our ground service agent eventually left the baggage tugs behind. He climbed into the cockpit of the Dash 8, reached for the center pedestal, and pushed the throttles forward. To leave the ground, he had to engage with a violently different set of physics, an open-loop system that relies on explosive, air-breathing combustion. This turboprop engine runs on a continuous four-stage mechanical cycle, described as suck, squeeze, bang, and blow. First, the intake aggressively sucks in huge volumes of atmospheric air. Compressor blades then crush that air into a tiny space, making it incredibly dense and hot. Then comes the bang. Jet fuel is injected into this compressed air and ignited, creating a continuous, contained explosion that wants to expand in every direction. This violent exhaust forces its way out the back through a turbine. This turbine spins a central shaft that runs to the front of the engine, driving the massive propellers that pull the aircraft through the sky. The airplane engine generates its power by violently processing the atmosphere itself, converting raw heat. Unauthorized flight ended in a crash on Ketron Island. In those final moments, the aircraft was functioning perfectly. It took the inputs of an untrained user and translated them flawlessly into physical motion, exactly as it was designed to do. Human engineering has become so successful that we have hidden incredibly dense physics, electromagnetism, and fluid thermodynamics behind a simple lever. We use invisible magnetic loops to glide across the ground, and we use contained, raging fires to conquer the sky. The laws of physics are indifferent to who is in the pilot seat. Through engineering, we have mastered propulsion so thoroughly that the power to move mountains now sits quietly at the fingertips of anyone.